Hi, Andrew with Evermore Studio. I was enjoying some cool polyhedra other people have made with laser-cut pieces. I even contributed panels to a community pentagonal hexacantahedron project a few years back. I wanted to make some small polyhedra, but the normal techniques of attaching faces to connectors or an internal structure seemed like a lot of work, especially at small sizes. I had an idea for another way to do it that worked out really well. The general thought is to make papercraft polyhedra with two laminated layers. The inner layer will be a heavy, rigid cardstock. I'm using some 380 GSM stock, usually black because it shows less between the panels. The outer layer can be another cardstock, wood veneer, a film, acrylic, fabric, or anything else you can laminate to the base layer. With careful testing and calibration, I work out settings for each combination that cut through just the outer layer and score the inner layer. For variable materials like wood veneer, I test each individual sheet to get optimized settings. Let's start with a wood veneer dodecahedron. I have this cold laminator/applicator that can apply an even coat of permanent adhesive. This could likely also be done by just applying an even layer of spray glue or perhaps glue brushed on by hand. Not burnishing the laminated pieces now will extend the bonding time for the adhesive and make it easier to delaminate portions of this after it goes through the laser. The vacuum table I made recently is great for holding the laminate in place for lasering. I cover the rest of the surface with scraps to maximize suction. The last face gets a cutout so that I can get a tool in to apply enough pressure to the final joint for a solid hold. Since there are two layers, I can replace the outer layer with an uncut panel after that. After cutting, I carefully take the veneer layer off of the tabs and the frame of the cutout face. Assembly starts by breaking each scored fold line. After a lot of experimenting, I found some PVA-like glue that dries to an adequate strength in about a minute and eventually becomes very solid. It takes some patience to hold each joint for a full minute, but this seems to be the best compromise for getting a durable finished product. I use the hole in the cutout face to slip in a little sprudger tool to make sure that the final joints hold well. Then I cover the hole with a single layer piece of the same veneer. Since these are hollow, I thought it would be fun to put a light inside one. For this, I'll do an icosahedron. The inner heavy black cardstock is laminated to an outer layer of heavy copper cardstock as before. In addition to the scoring and cutting done on the previous model, this one will have cutouts on the faces to let the light out. Despite the common recurrence of triangles in Celtic key pattern motifs, there aren't a lot of key patterns that are actually triangular in form, so I took a break from making polyhedra and designed one for this. A layer of translucent vellum on the inside will act as a diffuser and provide support for the fine lattice work. I used the same adhesive system on the vellum as I did for laminating the layers of cardstock. Some burnishing at this point makes the laminated layers quite integral. The usual CR2032 coin cell used in paper electronics projects is too big for the size of the icosahedron I wanted to make. With some poking around, I discovered this CR1216 coin cell, which is only 12.5 millimeters in diameter and puts out the same 3 volts as a CR2032 cell. This uses a Chibitronic circuit sticker LED, some plain washi tape to isolate the positive and negative terminals, and copper tape to form the circuit and switch. The battery and the LED end up on the inside with the switch on the outer surface. Assembly works the same as for the Dodecahedron. I apply the fast-drying glue to each joint and hold it in place for a minute. As before, one adjacent face is cut out and delaminated to make it possible to get a tool in for making solid final joints. The final panel of just the copper cardstock with a vellum diffuser on the back goes over the hole. A small magnet attracted to the battery inside keeps the switch closed. Ta-da! One magic orb to ponder. There are some new fancy LED circuit stickers that incorporate circuits for pulsing, blinking, and color cycling. Those worked erratically with the circuit I used for the copper Icosahedron. After building it over again 3 times, I concluded that I needed a circuit with more solid connections. I designed a simple battery holder that I could cut from a piece of 1/4-inch Baltic birch plywood on the laser. I laser cut a template and cut little pieces of some copper tooling foil I had on hand to be the contacts for the battery. After soldering short leads to those, they get glued into the battery clip with cyanoacrylate glue. I incorporated a reed switch into one side. The reed switch will turn on to complete the circuit in the presence of a magnet. This lets me keep the whole circuit inside my polyhedron. A little piece of heavy cardstock glued on one side of the wooden battery clip provides a little extra standoff between the contacts on the bottom of the circuit sticker and the battery contacts. Next, I solder the positive and negative wires to the pads on the circuit sticker. A quick test with a magnet confirms everything is working. Assembly is much the same as before. I glue the bottom side of the wooden battery holder and the bottom of the reed switch to the inside of the bottom face of the icosahedron. Once assembled, a small magnet will stick to the circuit through the cardstock and trigger the reed switch. Voila! We have a reliable pulsing icosahedron. These are a lot of fun. I already made a bunch, and I'm sure there will be other variations in the future. I will put the basic patterns up on the Evermore Studio site if you want to play with these. If you don't have a laser or access to one through a local makerspace, you could do some of these with some careful craft knife work and a metal straight edge.